Our next keynote, so it's our first keynote. Our first keynote is from Dr. Tao Zhang. So the topic of his keynote is edge computing. Where are we headed? So I'll give a brief intro to Tao. So Dr. Tao Zhang is a visionary leader who has been for 30 plus years leading research, product development, corporate strategy development, generating disruptive technologies and products in connected vehicles, fog and edge computing, mobile networks, IoT, and fiber optic networks. He is a pioneer in fog and edge computing. He has provided global leadership in the industry and academia and co-founded and led the Open Fog Consortium and is leading the fog and edge computing into a global mainstream industry trend and a vibrant research field. So currently Tao works for NIST USA and is a manager for emerging technologies. So Tao, we are privileged to have you give the keynote. So I invite you to start your keynote address.
Thank you so much, Rajesh. I'm trying to share, but it says it's disabled.
Tao, give me a minute.
Okay.
I'll make you a co-host, so that should make things easier.
Yeah,
So
I can see it now, I think.
Yeah. Are you able to do it now? Yes. Okay.
Yes. Can you see my slides?
Yes, sir. Yes, yes.
Yes. Hi everyone. This is Tao Zhang. Truly a pleasure to be here and an honor to be here to share some thoughts with all of us on fog and edge computing. I'll focus on a couple of areas that I think may be important going forward from this point. But before I start, let me once again thank the leadership from the IEEE, especially from the Standards Association and also the fog and edge industry community for sponsoring this event and making this event possible. Thank you so much, and it has been a pleasure sort of taking part in organizing it. So I'll start by going over very briefly where we have been in fog and edge computing, and then that will actually very naturally will lead into some of the next frontiers, some of the next challenges. People have been working on edge computing for many years. And for example, some noticeable achievement, some 20 years ago, and people started moving data toward the edge. And the result of that is the content delivery networks and web caching and so on. So many servers got stand up closer to the users and to host data and so on. Come early 2000, until around 2013, 14, that time frame, people have focused on moving applications and computing capabilities toward the edge. So started, for example, with running applications on some of those content distribution network servers closer to the users, to relatively recently, efforts done in many industry verticals to try to take advantage of edge computing. They're trying moving computing, for example. There are a tremendous amount of effort trying to move computing to the enterprise edges, to the mobile edges, that is mobile edge computing, more currently known as multi-access edge computing. And also there are people, quite a large scale effort, working on moving computing to the wired telecom edges, the central offices. So this effort actually focused on where computing should be. So moving computing closer to the users, but in a very isolated and siloed approach. And then around 2013 to 2015, so there was a significant effort represented by the Open Fog Consortium, and that basically recognized the need to actually look at this from the more systematic approach, and then to build an architecture that underlines the ability to compute and to actually make the computing and a seamless continuum extending from the cloud all the way to the things, and making it possible for you to do computing flexibly where it's needed, as opposed to be bound so tightly by the location of the computing. So I'll talk a little bit about that in the next slide, and that vision actually is playing out as we speak in the industry right now. So now the question is, what comes next? So there are, of course, many things that could come next, but one of the things that comes very naturally, I think is already happening, is now that we moved computing and applications closer to the apps, we were making great progress in building an architecture that can actually help us to distribute and move that computing functions end to end. The next thing, of course, is very naturally that we need to make those edge very intelligent. So not just doing computing, but also making the computing intelligent, making the computing more intelligently also integrated with communication. And so that actually movement has already started lately. So take a closer look at the continuum of computing vision or the fog computing vision. So the idea is that you want to be able to compute along that continuum between the cloud to the things and including on the things. You want to make the computing possible anywhere that makes sense. And to even in some cases, the computing may actually be dynamically deployed where it makes sense, and the user may not even want to know where. It could be partially on the user device, it could partially on the edge device, it could be sort of somewhere distributed across this this continuum and collaboratively working together to meet the user demand. So there are several important things that stand out in this vision. First of all, we're talking about a cloud-to-thing continuum of computing that's going to be enabled only by an end-to-end architecture that focuses on seamless integration between all these computing capabilities, as opposed to treating them as siloed or isolated devices or systems or applications. And so another interesting direction is that it should be an horizontal architecture, meaning that it should be an architecture that provide the fundamental capabilities for you to distribute the computing and to work with the computing, regardless of the applications you run on them, being net-connected vehicles or factory automation and so on, and as opposed to building an industry-specific set of overlapping capabilities. And a third sort of defining character is that an architecture or a capability like that should work not only over an existing network, but also inside a future network, recognizing that many advanced networks, for example, 5G and the coming 6G, is going to need not only edge computing, but the capabilities of distributing your computing to where it needed. So rather than building a separate and overlapping, again, functionally overlapping capability inside a 5G or 6G network to support that, the fundamental architecture of edge and fog computing should actually support that and already. So if you look at what's going on in the industry, if you look at where the products are going from the major players, both the cloud players and the network equipment players, you see this is where things are headed. And although we're taking on initial steps, we're not yet accomplished all the potentials of such innovation, but the industry seems to be headed this way. So then if you think, okay, now we have the architecture, now we can distribute our computing to different places. How do we make those computing smart? So I'll focus on two things. One is called Edge AI, the artificial intelligence at the edge, and also end-to-end collaborative AI. So think about how we are making today's edge devices smart. People are already talking about applying AI and machine learning techniques at the edge to learn and to make it smart. But in general, what we're doing is that we actually build our brains in the cloud. We train our models in the cloud because that's where we have all the data today. And then we distribute those brain or the results of those training, the models and so on, to the edge, to the network edge, to the people devices edge. And then those basically devices and the edge devices basically just use and brain borrowed or given by the cloud. But that actually is not going to be adequate going forward, because going forward, not only we need to learn in the cloud, but we also need to learn at the edge, and that's going to be necessary. So because a tremendous amount of data is being created at the edge. So you see it happening already, and you see all the predictions going that way already. For example, people are predicting many of those predictions. Say that in 3-year time frame from now, you're going to see 50% of the industry of the enterprise data created at the edge as opposed to in the cloud today. And Gartner, for example, predicts that 5 years from now, and you're going to have 75% of the enterprise data created at the edge. And you see that already in selected industries, like, for example, automated driving, like, for example, factory automation. A tremendous amount of data is being created at edge, and you cannot send all of them to the cloud because of the sheer volume and because of privacy considerations and other considerations. So that actually creates the necessity that says those data that you need them for training your AI and building your intelligence, and they're just going to have to stay where they are. You're just going to have to learn from those data where the data is, as opposed to trying to ship them somewhere first and then do your learning there. So that, I think, in a few years time frame, and definitely before the emergence of 6G, and it's going to become a necessity. So we're going to have to learn at the edge. So then comes the question, what's so important or what's so different at learning from the edge? So is it a problem already solved, or is it really a new problem? So if you look at learning at the edge, it carries several characteristics that actually make them fundamentally different from the traditional distributed learning that people have been doing. For example,
is going on, right?
The edge nodes and typically have constrained resources and data and also communication. Not only that, the data is actually often sort of unevenly distributed across the edge node. To the extent, for example, although some of the edge nodes together, they need to learn the same tasks, but they each may have only a partial data that they can use to learn to master only part of the task, like the blind people touching the elephant. Each of them sort of learned part of the elephant. And in extreme cases, you're going to see something like that. And also those edge devices can, in many cases, be more vulnerable to security compromises and so on. So you have to come up with ways to make sure that when you learn, and especially if you collaboratively learn, that you can actually make sure that the learned result are going to be robust, are going to be trustworthy. And another very rarely mentioned fact, but it's actually a fairly fundamental challenge, is that let's say you now can learn at the edge, different edge nodes, the cars and the network edge nodes, they learned what they needed to learn. But how do you validate what they learned is actually good before you let them sort of off to be used? Think about a car going around and learning things, and do you feel safe to allow that car just to use what it learned, right? So, and right now you have to go through a tremendous amount of validation in the cloud. And in the distributed edge learning case, validating what the distributed nodes learned is going to be fundamentally different. So none of, or very rarely, those challenges are tackled in today's or in the conventional distributed learning or collaborative learning work. So those make it very important and interesting. Another important aspect is that, as we realized from sort of edge computing, the past work, the edge is not alone. The edge is going to be part of a bigger ecosystem and a bigger application system. Collaboration between the edge and the cloud is going to be important, not only in learning, building sort of AI, but also in assuring end-to-end performances. So I'll use 6G as an example to show sort of how this is actually directly applicable in there. So if you look at what 6G is going to do, take a look at architecture traits. And of course, we all know sort of 6G research has just started, and it's not clear where it's going to end yet. But you started to see some fundamental things that are going to stay important. So first of all, and 6G is going to provide even more advanced support and differentiated support to user services. So that requires a set of very stringent and important capabilities that go beyond what you have today. For example, much stricter service isolation between those virtual networks or network slices, as we call it in 5G. And more importantly, to support the ultra delay sensitive and ultra sort of KPI sensitive applications like remote driving, like factory automation, like many other invasion 6G applications, you really need a better and capability to assure end-to-end service to some extent, which we cannot do with 5G yet. And one of the reasons that we cannot do it in 5G is because 5G, for example, right now, the major parts of the network, the cores and the access are still managed separately. And so they do not collaborate that much. You may give them fixed budget of delays or capacities, but they don't collaborate that much. And that won't be adequate to going forward to support. And with the rise of the edge, not only edge is there needed to support the ultra low latency, extremely low latency applications, and not only the big data we mentioned at edge, but more importantly, the edge systems are increasingly integrated with the customer system. Take 5G, for example. And in order to support industry automation, and we have this enterprise sort of mode of 5G that actually acts much like Wi-Fi, which can be integrated into a factory and being part of the customer system. That carries a lot of interesting implications. That means, for example, you're going to have to, that system has to inherit the customer's requirements, including performance requirements, security requirements, and management requirements, and data visibility requirements. So that no longer are solely managed by a network carrier. So the network carrier and the customer would then have to figure out a way what should be opened up to the customer, what the customer can or cannot do, what the network operator can or cannot do. So that all complicates things. So considering all of that, the control optimization and measurement becomes significantly more complex. The current way of doing things, that is, even in 5G, we still largely rely on mathematical modeling. And to handle all this complexity, mathematical modeling requires us to specifically and comprehensively and specify all of your requirements, all of your systems, all of everything. So that increasingly becomes impossible. And that is what I think 6G will need, and what I call all native, AI native architecture. And in that AI native architecture, edge AI and the collaboration between the edge AI and the core AI will be fundamental. Why do I say that? So today, people are building AI models for different parts of the network already, for controlling the end systems, for controlling radio channels, for controlling packet and services. But I think that's far from sufficient. Going to 6G, you're going to need an end-to-end architecture that are going to do a few things. That first of all are going to be able to help you distribute the intelligence, and from the cloud, from the back end, all the way along that continuum of computing to the end systems, and to enable collaboration by different pieces along this continuum to ensure end-to-end service, and to enable evolvement of this intelligence. So the involvement of intelligence means, for example, if you want the edge part of the system to become more intelligent going forward, then you have to, and the data is there, you can't move them too much, you can't move all of them to the cloud. And then the evolution will require you to learn over there. And so to manage the intelligence and to measure AI-powered performances, and by the way, that's not an trivial task, as we realize, for example, from today's difficulty of measuring and validating the safety levels of, for example, self-driving cars that use a lot of AI. And so that calls for edge AI, and especially learning, edge learning in AI, as opposed to borrowing your brain from the cloud just to make just to run on your edge system. But more importantly, the ability to actually learn to build your local brain from local data. And also, we need to teach those different AI modules, not only to perform their tasks, but also to teach them to learn to cooperate with each other. If they don't know how to cooperate with each other, you're going to have a hard time assuring anything end-to-end, as we have today. So having those different AI systems to cooperate with each other turned out to be not a trivial task either. So that opens up a lot of opportunities, a lot of research challenges as well. But what is important is that if you look at the next frontier of edge computing and edge AI, and how it's integrated into the computing continuum from the things to the cloud, you see they become very fundamental cornerstones of important things like the upcoming 6G. We all know that edge computing is an important part of 5G already, but 5G, the way 5G treated edge computing has some very fundamental limitation. It's still treated edge computing as an external device, external system behind and a gateway. So that actually make it very difficult for the edge system to integrate with the rest of the service management and service control of the 5G system. Come 6G, you're going to see much more integrated edge computing capabilities, and not only into the architecture, but also integrated with each other, and also cooperating with different parts of the system. So that type of a distributed and yet collaborative AI architecture is going to provide a transformational role, we think, for many industries, including, for example, automated driving, specifically remote driving, cooperative driving and teleoperation, and also factory automation, and all the upcoming very, very strict requirements that we're going to have to satisfy in 6G. So those are just two areas I think that's going to become the next frontiers in terms of challenges and opportunities in edge computing. I would characterize it as that over the next few years, we are going to evolve from edge computing to edge AI. So I'll thank everyone for the opportunity to share some thoughts. Thank you very much.